Hi, so today we'll be covering again Unit 1 functions, relationships, and linear, quadratic, and trigonometric functions. Here's a syllabus and you can see it under here. So relationships of functions. Y equals f of x, as we know, is graphed where it is able to cross the x or y axis or both. So you can see in this picture, if I make it a little bit bigger, here's a linear graph of y equals f of x. And it's going through y and x, just as a line. Now, y equals absolute value of f of x. We'll take the same graph and reflect an image along the x-axis, and usually never the y-axis. So let's go next slide. So when y equals f of x is linear, a linear function has the form of a y equals f of x equals a plus bx. The independent variables are a, and the independent variable is x, and the dependent variable is y. Linear function is basically the change in y over the change in x is always constant. So to better explain is that look at this little graph right here, this little mapping chart. And you see the values 1, 2, 3, 4, 5. So these are kind of like going back to our input and output values. Your input values are x, so it's 1, 2, 3, 4, 5, and your output values are 10, 12, 14, 16, 18. So don't worry about the equation or the function equation that they put these input values into. Just think about it like this. Here are your x values once again, and for a function to be linear, the x values must have a constant growth, in meaning that this has to have the same number apart from these two numbers and from these two numbers, and so on. And likewise, the set of y values must be approximately the same difference, or the same difference apart. Or the same growth rate apart. That's an easier word to remember it by. So 1 and 2, for example, they're 1 apart. So this is constant. But then to know that the rest of this column is constant, all you have to do is just say, how many is 2 away from 3? 1. How many is 3 away from 4? 1. And how many is 4 away from 5? 1. So even if this column, however, is constant, this y value has to be constant as well, because you're going back to the change of y over the change of x is always constant. So both of them have to be constant in growth. So 10 and 12, 2. 12 and 14, 2. 14 and 16, 2. And 16 and 18, 2. So this is constant as well. Now, I want to throw this out here because sometimes people get confused. The growth rates do not have to be the same amongst x values and y values, meaning that if this having a growth rate of 1, and this not having a growth rate of 1, but having a growth rate of 2, it's still constant. No matter if this increases by 5 and this increases by 3, as long as there is a constant growth individually amongst the columns, then the function will be linear. So let's practice on this. You have, does the graph shown below represent y as a linear function of x? And this is an easy one because we can already tell that this is not a line. This is kind of half of a parabola, maybe with a restrictions on its domain, but so this is not linear because you can tell by the shape, and you could possibly even go further to say that the domain and range values, as we already know, are not in constant growth. So let's go into this one when when y equals f of x is linear again. So now let's apply what we know about the relationship between y equals f of x and y equals absolute value of f of x. So practice. You see this graph right here. Here's y equals x. If we were to take away, we have this just little line. If we were to graph the y equals f of x onto this, again, it would be the reflection on the x-axis. So y equals f of x, or I'm sorry, y equals absolute value of f of x is always going to be reflected upon the x-axis. So I already have it written down here. If I remove this little white line, we can see your gray line, or your blue/gray line going down, is your y equals x. But then there's the addition of the y equals absolute value of x, which is upon the x-axis. So you have your linear function base of y equals x, but then you have the addition of y equals absolute value of x, reflected upon the x-axis. Okay, so when is y f of x quadratic? Quadratic function, a function in the standard quadratic form, ax squared plus bx plus c, where a does not equal 0. A quadratic formula will form a parabola when graphed usually, and it can be negative or positive. That's what's meant by upwards or downwards. Symmetrical is what a parabola is usually, and you will learn about axis of symmetry and the vertex. Vertex is just the midpoint. Axis of symmetry is taking the quadratic formula, which you probably will learn about, which is negative b plus minus square root of b squared minus 4ac over 2a, and axis of symmetry is taking negative b divided by 2a. This function in the quadratic standard form, which is again ax squared plus, to the second power plus bx plus c, must equal 0. So if it doesn't equal 0, you have to rearrange your formula that you're given so that all of the numbers will equal up to be 0, and the variables. There are other forms in which quadratic functions may be written. You have completing the square, factorizing graph coordinates. Okay, so let's practice. You have, let's say you're given x squared minus 5x minus 14 equals 0. So they're already giving you really an easy one where they already set you up to be in equal to 0. So that's good, but you're still in the standard quadratic form. So if they ask you to graph this function, you must put the given formula into factorized form. And this is basically it. It's where y equals a, which is a constant, times x minus q, close parentheses, and then open parentheses x minus p. So p and q are your x-intercepts. It's not x, it's p and q. Oh, sorry, I must have said that wrong. X minus q and then x minus p. But anyway, they are your x-intercepts. So let's turn x squared minus 5x minus 14 into factorized form by either the box method or a method of your own. So if we do that, then we would get, either way, open parentheses 3x plus 5, close parentheses, open parentheses, x minus 1, close parentheses. So you would then know that your x-intercepts would be 5 and 1. Bam, bam. Okay, so when f of x is trigonometric, a trigonometric function is usually a sine function. F of x equals sine x, as well as cosine, tangent, and the rest of these. But we don't think we'll have to get into these yet. These functions follow the right triangle in order to complete their operation. So basically it's looking at hypotenuse, adjacent, and opposite. So you have SOHCAHTOA that you can use to follow out these operations, which is sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So it's just basically meaning how you do it. So it's like division, yeah, so it would be sine equals opposite divided by hypotenuse, and so forth and so on. So when f of x is trigonometric, ways of notation equals y equals cosine of x, y equals sine of x, and y equals tangent of x. So here are the graphs that you should be able to memorize, because these are usually very common. And this is always going to be sine of x right here. Cosine of x looks similar right here. And then you have tan of x, tangent.